All right, so which of the following expresses the square of the distance? Okay, so we want to solve for r squared. So we have I equals p over 4 pi r squared. So we take this r squared and we move it diagonally across the equal sign, and it lands here. Then we take the I and we move it diagonally down to the bottom of the other side. And so our answer is just p over 4 pi I. That's answer choice B. For the same signal emitted by a radio antenna, observer A measures its intensity to be 16 times what B measures. The distance of A is what fraction of the distance of B? Okay. Right. So we're looking at the idea between intensity and distance r. So what kind of proportionality exists? Well, it's an inverse square proportionality. Okay, so what that means is that if I was to take r to 2r, then I would be taken to, let's see, 1/4 I. So what you do is you would flip and square the stress applied to the independent variable. So when we flip and square, we end up with 16 in this instance. So basically, we can then flip and square root to get back to the original. So flipping gets this, and square rooting would give us 1/4. So that means that the stress applied, R, must have gone to 1/4 R, because then the effect would be to flip and square. So we'd have gotten 4, and then 4 squared, 16. So I claim that the radius must have been 1/4. Okay, and that's answer choice A. The equation of a circle in a plane is shown. What is the radius of the circle? So we're going to have to complete the square. So we group the x terms together, and we group the y terms together. To find out the key number, we half the middle number here and square it. So that's 2, and then 2 squared is 4. So we add that to both sides. And we do the same for the y's. We half 2 and square it. So we get 1. Add that to both sides. Now we can factor these down, but basically the radius squared is going to appear on the right side. So we have already these ones cancel out, and we just get 4 is the radius squared, and so the radius would equal 2. The graph of a linear function f has intercepts a0 and 0b in the xy plane. If a plus b equals 0 and a is not equal to b, which of the following is true about the slope of the graph of f? So we want to find something about the slope. So we do change in y over change in x, right? So the change in y is b minus 0. And the change in x is 0 minus a. So we end up with b over negative a. In other words, we get negative fraction b over a. And we know that a plus b is equal to 0, which means that a is equal to negative b. And I could plug this negative b in for a. I get negative b over negative b, and that equals to 1. So we learned that the slope is equal to 1, if we did everything correctly here, which is a positive value. All right, the complete graph of the function f is shown in the xy plane above. Which of the following are equal to 1? Okay, so f of negative 4, so that's the value of the function at negative 4. So 1, 2, 3, 4. The value is at a height of 1, so that's good. F of 3, that'd be over 1, 2, 3. That height is also at 1. And f of 3 halves, which is 1.5. So at 1.5, the value of the function is at a height of 1. So I would say all 3. All right, this one looks like a lot of words, but let's go right to the question. Which of the following statements correctly compares the average rates at which the temperatures of the two samples change? So the average rate of change is a fancy word for the slope. Okay. Now, we'll start with the insulated one. And, well, I mean, the average slope is basically just the first and last points. So the average slope for the insulated would be smaller because it's less steep if you were to draw a best fit as compared to the version for the black dots here. Okay. Let's see what the choices look like. In every 10-minute interval, the magnitude of rate of change. Okay. Oh, I see. So the steepness starts out steeper for the non-insulated, but then it levels off faster. So it starts off steeper for the non-insulated. So, and that's, yeah, so that's the beginning. So from 0 to 10 and from 10 to 20, the rate of change of the non-insulated sample are of greater magnitude. So it would be this choice. Okay. In the xy plane above, ABCD is a square and point E is the center of the square. The coordinates of C and E are these. So C is 7, 2 and E is 1, 0. Where's E? Okay, 1, 0. Which of the following is an equation of the line that passes through the points B and D? So BD would be going this way. It would also go through point E because E is the center of the square. Right, so, well, we also know that these diagonals are going to be perpendicular to one another. So if we find the equation of the line for our first one, then we can take the negative reciprocal to get the slope of our one that we're dealing with. So let's start with 1, 0 and 7, 2. We'll find the slope. So the change in y, 2 minus 0 is 2. Change in x, 7 minus 1 is 6. So that slope is 1/3. Take the negative reciprocal of that, and we end up with negative 3 over 1. So we're looking for a slope of negative 3. So choice C and D are out. Now we just need to get the y-intercept. So if you notice, if you distribute the negative 3 through here, this will equal negative 3x plus 3. So it's either negative 1 or plus 3 for our y-intercept. And as you can see, it seems to cross at plus 3. So let's go with choice B. In the system equations above, A and B are constants. For which of the following values of A and B does the system have exactly 2 real solutions? Okay. Let's see here. So we can plug in 3 for y. So 3 equals ax squared plus b. And from here, there are several ways that we could solve this. Let's see. Let's think first about nature of roots. So we could subtract 3 to this side. Then it would equal 0. And let's see what we'd have for our discriminant. So we'd have a, b, and c. So a would equal, well, a, right? B would equal, b is not here because that would be the x term. And then c would be b minus 3. So b would equal 0. The discriminant is b squared minus 4ac. So it would be b squared. So 0 squared minus 4 times a times c, which is b minus 3. So we would get minus 4a times b minus 3. And then minus 4a times b is minus 4ab. And then the other distribution would be a positive 12a. All right, that's our discriminant. And I might be doing this the hard way, but let's see. We want our discriminant to be greater than 0 to have real solutions, okay? So we need this to be greater than 0. So we can come up perhaps with a condition on a and b. So let's start by dividing by 4. So in fact, we can factor out a 4. We'll be left with negative ab plus 3a greater than 0. Then divide by 4, so you just get rid of that 4 altogether. And then we would say that 3a, if we add ab to both sides, 3a is greater than ab. Then, assuming a is not equal to 0, which all the choices indicate, we can divide by a on both sides, canceling it out. And we need 3 to be greater than b. In other words, if we pancake that, b would have to be less than 3. So we cannot have any of these choices. We'd have to have choice A.